Alrighty. For this problem, we are given 4 points, and we're asked to figure out whether they are coplanar or not. And if they are not coplanar, find the volume with given adjacent edges PQ, PR, and PS. That's an S. So really, this is a pretty simple problem. Um, it kind of tells you there, find the volume, so we kind of know it's not coplanar. But we gotta actually figure it out. So the easiest way to go about this problem is trying to find the volume given these adjacent vectors, adjacent edges, and if we do get a volume, then we know that this is a three-dimensional object, and thus it has no points that are coplanar, or else it would be a two-dimensional figure, not a three-dimensional. Right. So let's go about finding the volume of this three-dimensional object. Right. So we're given these points P, Q, R, and S. Right. And we're also given that their adjacent edges PQ, PR, and PS. Right. So we are given points, and if we want to find a vector, we would have to just we'd go from P to Q. Right. So we would go the vector P to Q, right, would be 1 minus the 1 minus, subtracting their components, negative 2 minus 0, right, and 5 minus 3, right, and this would be a vector here, right, so this would be equal to the vector 0, negative 2, and 2. Now, hopefully I don't mess up my math. Then we have P to R. P to R would be 3 minus 1, 1 minus 0, and negative 1 minus 3. Right? And then that vector would give us something like 2, 2, 1, and negative 4, of course. Right? And then we have the final vector, which should be P of S, right? And that would be equal to 1 minus 1, and 2 minus 0, and 3 minus 3, which that in turn would give us 0, 2, 0. Right? So in order to find the volume given these three vectors, we gotta take the triple cross product, right? And we know a triple cross product would also look a little bit like this, right? Cross C. Right? So what I'm gonna do is, instead of calling this P of Q, I'm just gonna call it vector A. I'm just gonna call this vector A, and then I'm gonna call this vector B. Right? I'm gonna call this vector C. Just keep it a little simplified. Right? So in order to do this, we take the cross product of B and C, and then kind of have A as a scalar. So this would look a little something like this. Right? So we have 0, negative 2, 2, right? 2, 1, negative 4, and 0, 2, 0. Right, and that's just a simple, easy matrix to do. Right? So, writing this all out, we have a 0 in front, constant 0, constant 0, and let's see, cross this out, 1, right, we have 1 minus a minus 8, 1 minus a minus 8, right, and then we also have minus a negative 2, right. We'll have 2 times 0 minus 0 times -4, that just goes to 0, right? And then we go here, and then we have plus 2 times, what do we have here? 2 times 4, times 2 is just 4, right? Minus 0. Minus 0, right? So here, just summing all this back up, we get the volume here is going to be equal to, once you do all this summation and stuff like that, you're going to get to equal to 8, right? Meters, 8 meters cubed, because it's dealing with volume. Right? So we just figured out that this three-dimensional object has a volume of 8, and since we know that the volume is not equal to 0, then in fact that none of the points are in fact coplanar. Right? How's that?